Hi everyone, today we are treating equilibrium of forces. In our daily lives, we have seen different bodies and their different ways of movement or stability. Carrying a heavy bag is easy by two people each holding it with handles. So also picture frames hung on the wall is balanced by ropes. Children on seesaw exert different weights on the seesaw and their weight is balanced by the reaction from the seesaw. Learning outcomes. By the end of this lesson, we should be able to define equilibrium, differentiate between equilibrant and resultant forces, differentiate between static and dynamic equilibrium, solve problems on objects kept in equilibrium by number of forces. Now, definition of equilibrium. Equilibrium is the condition of a system when neither its state of motion nor its internal energy state tends to change with time. Concept of equilibrium. This tells us when a body is in equilibrium. When is a body in equilibrium? A body is said to be in equilibrium when the body as a whole either remain at rest or move in a straight line with constant velocity. A body is also said to be in equilibrium when it is not rotating at all or is rotating at a constant angular velocity. Types of equilibrium. Number one, we have dynamic equilibrium. Dynamic equilibrium occurs when a body is in a straight line with a constant velocity or zero acceleration. A body can also be in static equilibrium. This occurs when the resultant force on a body is zero and yet it does not rotate or turn about any point. Types of dynamic equilibrium. We have two types of dynamic equilibrium. This can be one, translational or rotational. Now we move to resultant and equilibrant of forces. The resultant force is that single force which, acting alone, will have the same effect in magnitude and direction as two or more forces acting together. Looking at the example there, we have F1 and F2. F1 is a force, F2 is another force. A line drawing from that point of intersection of the two represents the resultant force. The equilibrant. Equilibrant of two or more forces is that single force which will balance all other bodies taken together. It is equal in magnitude but opposite in direction to the resultant force. So in the diagram, the arrow pointing outside is the equilibrant forces. Now, triangle of forces. Looking at that diagram, we have F1, F2, and F3. All those three forces meet at a point. The equilibrant of F1 and F2 is F3. So also, equilibrant of F2 and F3 is F1. So also the last one. When we look at this body, it can be arranged to form a triangle. And when it forms a triangle, it helps us to calculate the angle needed or the side that is needed. We move to the examples. In the diagram, we have a body, a rope tied to a rigid body. The question says the diagram above illustrates three forces, which are T1, T2, and the last one 250 Newton. Why are T1 and T2 forces? Since we have said that they are supported, we have defined equilibrium of the forces. The line T1 is joined to a rigid body and makes it to be taut, hence have tension in it. And since tension is a force, T1 is a force, T2 is a force. This can be resolved to form a triangle. And we must know from the triangle of forces that all the arrows, the direction of the arrows on each of the forces should remain unchanged. So the weight of the body on 250 faces downward, T1 is pointing upward, and T2 lies horizontal. So this question can be solved using Pythagoras theorem. And hence the angle can be found. The angle is found looking at the diagram, the initial diagram, which is 30. So we'll use SOHCAHTOA. Tan 30 is equals to opposite over hypotenuse. Our T now gives 250 tan 30, which is equals to 0.577 times 250. And our value goes on to 144.3. Question 2. A body of weight 5.0 hangs from the free end of a piece of wire whose end is fixed to a rigid support. A horizontal string attached to the body exerts a force which keeps the wire at an angle 300 to the horizontal. Find the tension in the string and the wire in the diagram below. So this one too, we have to rearrange it to form a triangle. The angle which the string make with the wall is 30 degrees. So using our SOHCAHTOA, we can say our tan T1 is equal to 5 tan 30 degrees. So 30 degrees tan 30 degrees gives 0.5775. So our T1 becomes 5 times 0.775, which is equals to 2.989. And the last aspect can be calculated using Pythagoras theorem. Self-assessment. Since we have seen how to form a triangle from forces, we should be able to lay our hands on the self-assessment. In conclusion, now that we have been able to see what is equilibrium of forces, we should be able to apply it in our daily lives, in balancing or carrying objects, and also solve problems. Thank you and God bless.